Welcome back to NeonSync AI. We need to talk about the single biggest flaw in modern artificial intelligence. Right now, massive foundation models like GPT-4 and Claude are fundamentally static. They are frozen in time. Once their initial training finishes, their internal neural weights are permanently locked. They cannot learn anything new without a massive, multi-million-dollar server retraining process. If a self-driving car algorithm encounters a completely untested weather condition on the highway, a static model immediately struggles. It relies entirely on its limited past training data. But imagine a completely different approach. What if an AI system could adapt perfectly on the fly? What if your software code could literally rewire its own synthetic brain in real time? Enter the liquid network. This is a radical architectural paradigm shift emerging directly from the MIT Computer Science and Artificial Intelligence Laboratory. Researchers have successfully built a neural architecture that continuously adapts its parameters long after the training phase is over. It learns from new telemetry data streams instantly. This is not just another incremental software update for developers. This is the legitimate birth of dynamic artificial intelligence. Fully understand the mechanics of liquid neural networks, we have to look away from silicon chips and look closely at biology. The MIT research team did not model this architecture after the massively complex human brain. They modeled it after a microscopic biological roundworm called Enorhabditis elegans. This tiny resilient organism has exactly 302 interconnected neurons in its entire nervous system. Despite having this microscopic brain size, the worm can perfectly navigate terrain, track food sources, and survive incredibly complex environments. This incredible biological computing efficiency comes directly from the worm's extreme synaptic flexibility. Its neural signaling pathways change behavior dynamically based on immediate real-time environmental feedback. Liquid neural networks replicate this exact biological elegance purely in code. Traditional deep learning nodes use highly rigid mathematical activation functions. Liquid nodes use complex differential equations dictating continuously evolving internal cell state. The digital connections between the individual nodes are literally fluid. Core parameters shift constantly depending on the sequential data flowing rapidly through them. They dynamically filter out useless noise while amplifying the critical signal. The real-world applications of this dynamic technology are absolutely staggering for the industry. Let us look closely at completely autonomous drone navigation in highly dense environments. A traditional deep learning model requires tens of thousands of parameters to process complex video feeds. If you manually move that static test drone from a bright summer forest into a dark, blinding winter storm, it fails catastrophically. The static compute nodes simply cannot cleanly calculate the wildly unexpected visual atmospheric noise. Now drop a newly deployed drone powered by a liquid neural network into that exact same intense storm. The liquid nodes instantly recognize the heavy visual interference as a completely new variable environment. The underlying math equations dynamically adjust their own internal sensitivity thresholds instantly. Drone magically stabilizes and carefully navigates perfectly through the heavy blinding snow. The agile AI literally adapts its own digital understanding of the real physical world on the fly. This massive sudden leap in software robustness is incredibly critical for modern military and commercial aviation logistics. Self-driving cars naturally face the exact same chaotic physical unpredictability on crowded urban city streets. Liquid neural software architecture practically provides the missing fundamental biological resilience that static silicon chips completely lack. But the single most massive disruptor here is the sheer unprecedented scale of raw computing efficiency. We are currently facing a massive global AI hardware energy crisis due to massive commercial server farms. Training static massive language models requires thousands of extremely power-hungry GPUs running non-stop for months. Liquid neural networks violently shatter this outdated brute computing paradigm completely today. Because liquid math nodes are so incredibly highly expressive, you need vastly far fewer of them to achieve high baseline performance. In a recent official MIT autonomous driving software test, a traditional neural network needed millions of rigid parameters to steer correctly. Liquid networks smoothly accomplished the exact same complex driving task with just 19 liquid nodes. 19. This massive sudden reduction in heavy computational overhead changes the entire global hardware landscape overnight. You no longer strictly need a massive fast cloud server connection to run advanced autonomous AI models locally. You can actually run hyper-intelligent, fully adaptive AI directly on the low-power edge hardware itself. It can run seamlessly today on a simple smartwatch, a local factory monitor sensor, or a remote portable medical device. This is the ultimate total democratization of high-level industrial artificial intelligence. We are currently witnessing a massive fundamental fork in the road for global artificial intelligence software development right now. Massive tech giants like Microsoft will certainly continue building massive trillion-parameter foundation models in huge centralized cloud data centers. They absolutely need that raw, massive foundational processing power purely for complex generative text and video creation purposes. But the tangible physical hardware future firmly belongs entirely to agile liquid neural networks. When you need a manufacturing industrial robot arm to adapt instantly to a completely new heavy shifting payload weight in real time, you urgently need a deep-sea autonomous military submarine to navigate previously uncharted and turbulent dark waters flawlessly without a fixed remote connection. Liquid networks practically provide the exact biological agility and flexibility essentially required for real physical world perfectly, and this new emerging software technology effectively bridges the massive gap between dead static software and living responsive biological systems today. Are massive, slow, static cloud foundation models destined to naturally become slow, extinct dinosaurs in a fast-moving, dynamic hardware edge environment? We highly want to hear your expert technical take on this massive hardware paradigm shift exactly. Thoughts and industry predictions quickly in the lively comments section down below right now today. If you eagerly want to absolutely stay aggressively on the absolute bleeding edge of the fast tech revolution daily, smash that big subscribe button hard right now. Turn on priority notifications today so you never miss a deep technical breakdown video ever again on our channel. This is the front line of the modern global digital edge, and you need to be perfectly equipped early. Let us build the bright adaptive tech future together today, one rapid high-speed minute at a time. Stay ahead of the curve. NeonSync AI out.